Okay, so we're looking at applications. Average cost, just a reminder of our function C of x. You write it with C of x with a horizontal line over it, and that is equal to the cost function over x. So if we're trying to find the average cost of something, that's the formula we're going to use. Average revenue is similar, average profit is similar. You just have that revenue function with a horizontal line over it, and that's the same thing as your revenue function divided by x. If we're looking at marginal, when it has the word marginal in there, average cost, this is if the total cost of the manufacturer X items is given as C of X, then the average cost, which we just said, per item is that C of X, our cost function, written and denoted with that horizontal line over it, which is equal to our cost function divided by X. If we are looking at the marginal average cost, this is the derivative of this average cost function. And we could denote that with C prime of X with that horizontal line over it. And so let's look at an example where we want this. And so here we have that the total cost in hundreds of dollars to produce X units of perfume is the following. So C of X is equal to 3x plus 2 all over x plus 4. And we want to find the average cost to produce 10 units, 20 units, and X units. And then we want to find the marginal average cost. So I think it's easier if we start with C. So we want to look at it for X units. And once we find the average cost of X units, we can find the average cost of 10 units and 20 units. So we want to find the average cost, and we just said that the average cost was denoted with the cost function, and that was your cost function divided by X. So we can do that. In our case, our cost function is this 3x plus 2 all over x plus 4. And then we want to divide that all over x. Okay, so we don't really like complex fractions, but this one can be manipulated really easily. Think of this as we have a fraction divided by a fraction. A divided by B divided by C divided over D. This is the same thing as taking A over B times the reciprocal D over C. So the same thing as 3x plus 2 divided by x plus 4. This is divided by x over 1. We're going to rewrite it as multiplying by the reciprocal of the second fraction. So we found that the average cost function is equal to, well, fraction times a fraction, we can multiply the numerator together. So 3x plus 2 all over our denominator, x times that quantity, x plus 4. So here's our average cost. So now, if we want to find the average cost to make 10 units, so part A, we would look at C of 10. So we're going to go in here, and wherever we see an X, we're going to replace it with 10. So this is equal to 3 times 10 plus 2 all over 10 all times the quantity 10 plus 4. So simplify using order of operations. We have 3 times 10 is 30 plus 2 all over, inside the main parentheses first, 10 plus 4 is 14. So we have 32 over 140. I probably would reduce this, but I also noticed that I need to put this because I'm talking about dollars, it makes more sense to me if this was in decimal form. So 32 divided by 140. So this is equal to 0.22857 approximately. We want to remember, though, in our original problem, or when it was asking us, it told us that the total cost is in hundreds of dollars. So this is 0.22857, and I could round that up. Hundreds of dollars. But let's just multiply that by 100. So if I multiply that by 100, that's going to move my decimal over twice. And so this is just the same thing as $22. And let's round the 5 up to 86 cents per unit. So the average cost to produce the 10th unit is $22.86. So we could do the same thing with 20. All we would do is go in here instead. For B, we would plug in 20. To save time, because we're almost out, let's just jump to finding the marginal average cost. And so the marginal average cost, that was the derivative of this, which we found. So for D, we have, let me just write it down here again. The average cost was 3x plus 2. If I'm going to take the derivative of this, I don't want to have to, I'm going to have to use the quotient rule, and I don't want to have to use the product rule with that. So let's distribute this x while we rewrite this in the denominator. And so that would give me in the denominator x squared plus 4x. So now we can take the derivative of this average cost function. We're going to use our quotient rule. So the derivative of the numerator, 3x plus 2 is just 3, all times the denominator, x squared plus 4x, minus the numerator, 3x plus 2, times the derivative of this denominator. So derivative of x squared is 2x, plus the derivative of 4x is 4, all over the denominator squared, x squared plus 4x, quantity squared. So I'm just going to distribute, combine like terms. So distributing my 3 to the first parentheses, I get 3x squared plus 12x minus, and if I FOIL this out, so 3x times 2x is 6x squared. I have a 3x times a 4, so that's plus 12x. A 2 times the 2x is plus 4x, and a 2 times 4, so plus 8. All over this denominator squared. If I distribute my negative and start combining like terms. So right here, my two middle terms, 12x plus 4x is 16x. So it's going to be a minus when I distribute it. This is going to be a minus 16x, and this is going to be a minus 8. So let's just combine like terms. We have a 3x squared minus a 6x squared. So that's a negative 3x squared. And now we have a 12x and we have a negative 16x. So 12 minus 16 is minus 4x. And we have minus 8 all over this x squared plus 4x quantity squared. So we just found the derivative of that. So we just found the marginal average cost.